Hello, this is KV7006 machine learning module. This video is about the naive Bayes classifier. So we have learned classification in principle. Naive Bayes is one of classic classification methods in machine learning. So during this session, we are going to understand what is the purpose for classification, which we learn from historical data, and use the model we have learned to identify the class of new sample. And then we will start to do this through an example by hand. And then we understand the formula to be used for calculation through one simple example. And then in the lab sessions, we are going to use software tools and the Python packages for you to practice and use naive Bayes classifier. Okay, first, we have a look at the example. At the beginning, we look at the table. We have 6 records here, which is historical data. The first column is a symptom. It's one feature, which you can see we have sniff, headache, as two value of these variable symptoms. Profession is another feature. This table shows that we have nurse, farmer, builder, teacher. So 4 types of value for profession. Disease is a class which has been made by doctor, nurse, which you have to treat as ground truth. Of course, this is a simplified example. In fact, this in real world should be more complicated. So 2 features. One has 2 values, another feature which have 4 values. Okay, so the disease is classes which have a cold, infection, brain injury, 4 values of this class. Okay, given these datasets, record 1 to 6, now I'm having a new samples come in, which a patient whose profession is builder, and he or she has a symptom of sniff. Has he or he got a cold or infection or brain injury or whatever? What kind of disease it should be? Okay, so they have 4 probability. Okay, the new patient, which is a builder who has symptom of sniff, he could get a cold or infection or brain injury. So how are we going to calculate the probability of that? Probability of cold, probability of infection, brain injury, based on these 6 records we have seen before. And then we calculate the probability of this cold, infection, brain injury. So by doing so, we know what is the probable, very possible, what is the highest probability this patient has, what type of disease he has. Okay, so I'm giving an example on your right-hand side. So in this case, we only calculate the probability, estimated probability of this sample, which has class of cold. However, the same principle can be applied to infection and brain injury. So you could practice later on. So I got your homework later on for you to practice the probability. Okay, so the question now becomes, we have a new patient. What is the probability this patient has cold? Okay, so probably before we calculate, you have a think. Given the data set, what's your, intuitive way to solve this problem? Okay, the first step to use a naive Bayes classifier is calculate the probability of a related class and the features. So here on first section, you can see I calculate probability of code, because this is a class we are going to calculate. We also calculate the probability of sniff, because this symptom of the patient has this symptom. We also calculate the probability of builder, because this patient, new patient, has this value of features in his job, this in his professional feature. So to start with, we calculate potential class label probability in the dataset, okay, and all values of related features, their probability. So I hope that is clear. And then how we calculate the probability of code. So in total, we have 1, 2, 3, 4, 5, 6 sample. Okay, the code come out of 1, 2, 3 times. So that's why I write 3 divide 6. Similarly, we got 6 records. 1, 2, 3. 6 of them has sniff, and we got 6 records, 2 builders. Okay, so I hope that is clear now. The next step is a little bit more complicated. So, code is the class we are going to calculate for their probability of this case. So this new record also have 2 values on the features. One is sniff and one is build. Based on the condition of code, what is probability of sniff on the historical data? So look at the code. We have 1, 2, 3 code. Look at sniff. We have hold on. So this is something I need to remind you. Okay. So only when the condition become code, we count the sniff. We are not counting total number sniff, but we only count the previous patient who has code, has sniff. Okay. So first record first, and the record fifth. Okay, so I've got 2 records out of the patient who has code. Both of them have sniff. Okay, again we do similar things. Only look the code. Okay, so how many of them in the records, 6 records, they are builders? First one no, second one no. The builder, this is builder, but disease brain injury. Here's one builder, they have got code. Okay, so that probability is 1, because only record 4, when they have code, the profession is builder. Is that a little bit clearer now? Okay, now we move on. Because this patient who has both symptoms of sniff and his builder, okay? So now we calculate the probability of, on the condition of sniff and the builder, what is probability this patient got code, okay? Now we practice a formula we were going to study in the next slide, okay? Basically, we practice this formula, okay? So this is class, code is class. So what is this is class. So on this condition of this class, what is the probability of feature 1 times on this condition, what is probability of the feature 2 builder, feature 1 sniff. Okay, and also times the total probability code. The reason is that you can see the total probability code is only 50%. Okay, so other disease occupy the half of the existing record. Then we divided by probability of sniff and the probability of builder. So actually we need a bracket here. Okay, so we put the value in. Okay, we'll put the condition of code, sniff. So put this value in here. and then code and builder times this one, and then time probability code 50%, and divided by probability of sniff divided by probability of builder, and in total we work out 0.66. So what this 0.66% tells us, given the two features value, which is sniff and the builder, the probability of this patient who has got a cold is about 66%. So because we have already learned probability theory, so the total probability all possible of cold, infection, brain injury altogether should be 100%. So in other words, another two disease, infection or brain injury, owning both together only count 34% of probability. Therefore, this cold is most likely disease this new patient has got. Okay, so this gives us a concrete example on features, two features. One class is how are we going to calculate the probability of one class. So automatically your Python package will calculate that for you. Okay, so this helps us understand the basics. So next slide, we are going to give a briefly Bayes theorem and what is naive Bayes. Okay. This is the formula we have. Let's just give me 1 second. So this is the same question. Okay, so that is simplified. Okay, just give me 1 second. Okay. So we have used this formula. Okay, we have used the second formula. Yeah, okay. So this is the Bayes theorem. Okay, so what this tells us is like, okay, let me explain. C is condition. Okay, A is let's say event or new record or whatever. Is something features we have data. C is something we need to calculate. Given this condition, give this situation, give the features of, for example, sniff or builder, there could be combination, okay, other features, value of other features. It could be other potential. So if this case we have more features, we will see longer expression here. Both use AND to join them together. Okay, so these things describe new record. It's a model. They have two features, each equivalent to a particular value. C is something we want to predict. Okay, so that is a formula. First, we have a probability. You can see the reverse order. On this condition, what this kind of feature happens. So, but this case, we don't have. We don't have, on the condition of cold, sniff and the builder. You can see cold, sniff nurse, cold, headache builder, cold, sniff and teacher. So there's no record so far about the sniff and the builder. Therefore, we cannot use directly, and I will explain how we do that. And then probability of the class. So you can see that this class is not always happen. So they have other proportion, large proportion of other disease. Okay, and divided by the actual by the features, joint of features. So as we seen before, so this should interpret as code class features, statement of features equivalent to feature statement, condition, class, and times class divided by probability of all features in a joint statement, understatement, okay? Because we need to simplify it, because we cannot calculate this. The reason is that in our previous record, we didn't have any record like that. So we have to use different way to calculate in this case. Because we assume that sniff and builder are independent. So I think we know what dependent means in terms of data mining. In the regression model, linear regression model, we already know what is independent variable, what is dependent variable. Dependent variable means these two are rely on each other. For example, housing price, I always use this case because it is quite easy and in our daily life. Housing price is always depend on location in most cases. So that is dependent variable on independent variable in that case, which is location. It is unlikely, very rare case, location is dependent on the housing price, another way around, because location is always there. So the city will be there, they won't change because the housing price, right? So that is a typical example of independent or dependent variable. Here we assume sniff and the builders are independent to each other. More or less is true. So because of this, we can revise the formula in order to address the situation that we don't have any record which have us calculate probability of sniff and builder and condition of code. So what we could do is, we think because they're independent, so we calculate the probability of the code. First is sniff, calculate the code, first is builder, we time them together because they are independent. The probability will the times of the probability, okay? And then this is the same probability code, we copy paste. And then similarly, we can replace probability of sniff and builder to the probability of, sniff and the builder. We can time up them together. Because this actually means, first, if probability of sniff is happened like 10%, probability of builder is happen 20%. Or let's say this way, if probability of sniff, let's have a look at the previous example, is 50%, okay? Probability of builder, let's see, is 1/3. One is 6, builder is 2/6, one is 3/6, okay? So the probability is 1 divided by 6. Okay, so that gives us the answer, okay? Okay, so now we are going to summarize. So this is the theorem, okay? So we practice this theorem given the assumption of independence. So, in summary, the most important thing is we understand the independence of the variable. If these variables are not independent, we shouldn't use this formula at all. Because you will later know that if two variables are, for example, principal component analysis, if some variable depend really on other variables, you shouldn't use dependent variable on. But anyway, so if, for example, this features is fully dependent on this one, you could use this one to predict this one. So you shouldn't use the formula I have just mentioned, because this formula, this column have meaningless, because given this value, you can predict 100% accurate on another feature, so this feature can be removed. So in future, we'll learn the reduction of dimension. In that case, you probably will understand a little bit more. But at the moment, we have to assume all features are independent. So, and then we apply the estimate to the data, use Bayes theorem. So you could, if you want to understand a little bit more, there's book in library. I think we have 3 copies, hard copies. You probably also got the online copy, which have a very detailed understanding of all machine learning methods. It's called Art and Science that makes sense of data. It's a machine learning textbook. Okay. So before we end this video, I'm going to invite you calculate by hand about another patient who has a headache, who has a FOMA. What is the disease he probably got? You can predict cold and or infection or brain injury, and to see what is the probability which is highest among these 3 diseases, and then you fully understand the principle of naive Bayes classifier. Thank you very much. I see you in another video. Thank you.